right, so sim review questions 25 through 37. At a clothing store, Zoe bought 2 shirts for $7.25 each. And so each is a nice keyword. Each usually means to multiply or divide. If I know the total, I can divide. If I'm looking for a total, I can multiply. In this case, I don't know the total, so I would be multiplying those numbers together. And 2 pairs of jeans for $24 each. So again, I don't know the total, so I will multiply. And a coupon for $10 off. So now I would subtract $10, the total price of the clothes. The discounted price of the clothes Zoe bought can be found using this expression. So they gave it to me, but even if they didn't, I could figure it out because I know I have 2 times $7.25. I see that here. I know I have 2 times 24. I see that there. And then I have my $10 off. So if I needed to figure it out, I could have figured it out, but they were nice enough to give this to me. So let's continue on. What is the discounted price in dollars and cents of the clothes Zoe bought? So I'm going to rewrite this so I have some room to work. I have my 2 groups of $7.25. I have my 2 groups of $24. And all of that is in brackets, less my $10. And of course, I have a strategy that lets me deal with this, which is going to be GEMDAS. So GEMDAS is I do groupings first. I have multiple groupings, parentheses, and brackets. And so as we've discussed in class, I do the innermost groupings first, the insidemost groupings, and I have 2 inside. I have parentheses and parentheses, so they're the same rank left to right. So 2 groups of $7.25, so if I have $7.25 twice, my 2 $7 is $14, and then my 2 quarters ends up being 50 cents. 2 groups of $24, that gives me $48. I do still need my brackets, and just bring down the rest. $14.50 plus $48. Well, my $14 plus my $48 is $62, and I still have my 50 cents. Bring the rest down. Now I'm done with grouping, no exponents, no multiplication or division, but I do have addition or subtraction. In fact, I have subtraction. So $62.50 minus 10 will give me $52.50. And so I just need to make sure that I take note of where my decimal is, fill in my numbers in the appropriate place value, and then just fill in my bubbles. So, and again, as we talked about before, you don't have to put this leading 0 here. You can if you want to, and that will be a correct answer. Or if you left it off, that's still a correct answer. Number 26. A table of ordered pairs is shown. So I have some ordered pairs, and I need to know which graph represents the ordered pairs. So I'm just going to go through all of them and see which ones match. So 2.5, 5. So start at my origin, go over 2.5, go up 5. And I do have that number here. Let's look. 2.5, 5, and nope, that one's not there. 2.5, 5, that one's there. 2.5, 5. Okay, the next ordered pair, 3.5, 7. So I'm going to go to 3.5, go up to 7, and nope, that one is not there. 3.5, 7. That one is here. 3.5, 7. All right. Still got 2 more left. 4.5, 9. So I don't need to check the ones I've already eliminated. So I'm just going to check these other 2. And they're both there. 5.5, 11. Start at the origin. run 5.5, jump 11, run 5.5, jump 11. Last one, 6.5, 13, run 6.5, jump 13, run 6.5, jump 13, and can eliminate another answer choice. So that leaves me with H as my best answer. Number 27, a company makes 625 cell phone cases each day. So I'm going to either multiply or divide. How many cell phone cases does the company make in 31 days? So here I don't know the total. I know in 1 day. I know for 31 days. So I'm looking for the total, so I will multiply 625 times 31. And then 1 times 5 is 5. 1 times 2, 1 times 6. Tick, tack, 0. 3 times 5. 2 times 3 is 6, plus 1 is 7, and then 18. Add up my partial products. That gives me 5, 7, 13, 9, 1. So 19,375. I do have an answer choice that matches that, so we are good to go. 28 is a properties of polygons. So this is going to be in our geometry unit. We're not there yet, but we should have learned enough in 4th grade to be able to help us out. Right angles only. So squares have 4 right angles. Rectangles have 4 right angles. We look good here. Now it does tell us which shape was not classified correctly, so I'm looking for something that is incorrect. Acute angles only. So let's see, that's smaller than 90 degrees. That's acute, acute, acute. This is acute, that's acute, but then I look and that is an obtuse angle. That is an obtuse angle. Those are bigger than 90 degrees. Looks like shape 4 is probably my answer. Let's keep looking though. Obtuse angles only. Yep, those are all larger than 90. These are all larger than 90. So both acute and obtuse. Acute, acute, obtuse, obtuse. Obtuse, obtuse, acute, acute. So those are all good. So it looks like shape 4 I have been able to confirm is my correct answer. Is the one that is not classified correctly. Question number 29 talks about a dot plot. Now we'll talk about this a little bit more in our statistics unit. But it's the number of pets owned by students. And so if I'm looking right here, I have 5 students that own 0 pets, 3 students that own 1 pet, 9 that own 2 pets, and so on. So it's asking me what fraction of the students in the class have 2 or more pets. So that's some key information there. And so I'm looking 2 or more. So I have, looks like 8 students with less than 2. And then 9, looks like 16 students with 2 or more pets. But it asks me what fraction of the students. So looks like 16 have 2 or more out of a total of 24 students. Well, 16 out of 24 is not one of my answer choices. So that means I am going to need to simplify. So I need a common factor of 16 and 24. And so if I list out my factors of 16, that's 1 and 16, 2 and 8, 4 and 4. So common factors of 24. That looks like 8 is going to be my greatest common factor. So if I divide by 8, 16 divided by 8 is 2, 24 divided by 8 is 3, 2/3, and yep, that does match an answer choice, so I'm good to go. Question number 30, the table shows the number of hats made at a factory during 3 weeks in February. The number of hats in week 4 is represented by the number n. The total number of hats was 2,148,431. Which equation represents the situation? So how would I figure out how to make the total? Well, the total is going to be the sum of all of my 4 weeks. So week 1 plus week 2 plus week 3 plus week 4 will get me my total amount. So I'm just going to be adding. So I look here. Nope, not dividing, not multiplying, not subtracting. In fact, I am adding. So F will be my best answer. Number 31, Dwayne packed some books in a box shaped like a rectangular prism. The volume of the box is 168 cubic inches. Which model could represent Dwayne's box? So I need to know which of these, when multiplied together, will get me 168. So again, my volume is simply my length times my width times my height, or I could say that my volume is my base area, the area of my first layer, times how many layers tall it is. So here I have 10 times 16 to get this base area. So if I build that first layer, that's a 10 times 16, which is 160. So that gets me 160, and I'm going to multiply that by 8 layers tall. That's going to be way larger than 168, so that won't work. And if you don't believe me, you can go ahead and multiply it out. Here I have a 6 by 6 that gives me 36 as a base area. Multiply that by 14. 6 times 4 is 24. 4 times 3 is 12. 13, 14. Tic-tac 0. And then 36. That gives me 4, 10, and 3, 4, 5. That's way larger than I need. I need 168, so that's no good. Over here, my base area is 28. 28 times 10 is 280, so that's too large. And so let's see if this is the right one. So here we go. 7 times 3 is 21. 21 times 8. 8 times 1 is 8. 8 times 2 is 16. And yep, that's what I'm looking for. 168 cubic inches. Number 32. Customers at a gift shop receive free stickers for every t-shirt they buy. The graph shows the relationship between X, number of t-shirts. Yep, see t-shirts is on my X axis. And then Y, the number of stickers. And so what I notice is that 6, 6, 3, 6, 12, 6, 18, none of these are actually on my graph because 6, the highest that my graph goes, looks like 11. And so it's not 6, 3, so I could eliminate that one. It's not 6, 6, I could eliminate that one. But 6, 12, 6, 18, I'm not really sure. So I could probably eliminate F and H, but I'm just really not sure what's going on just yet. So what I'm going to do is I'm going to look at the information that they gave me. So I'm going to make a quick T-chart. T-shirts and stickers, or you could say X and Y if you wanted to. And I'm going to graph the points, or make a table of the points that are on the graph. So for one T-shirt, it looks like 2 stickers. From 2 T-shirts is 4 stickers. 3 T-shirts is 6 stickers. 4 T-shirts is 8 stickers. And I'm trying to see, do I notice a pattern? How do I get from 1 to 2, from 2 to 4, 3 to 6, 4 to 8? Looking for my rule, and it looks like my rule is I'm multiplying by 2. 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6. So I'm looking for a rule of times 2. So when I look here, 6 times 2 is 6. Nope. 6 times 2 is 3. No. So I've confirmed I can rule out those two. 6 times 2 is 12. That looks good. 7 times 2 is 14. 8 times 2 is 16. 9 times 2 is 18. G looks pretty good. 6 times 2 is 18. No. 10 times 2. No. So then my correct answer is G. Number 33. Tara has a box of 908 beads. She wants to put 15 beads on each bracelet. What is the greatest number of bracelets that Tara can make with these beads? So here I have a total number of beads, 908. She's splitting them up into groups of 15, using 15 beads on each bracelet. So that's going to be division. So 908 divided by 15. How many 15s are in 9? 0. How many 15s are in 90? I'm not sure. 15, 30, I'm just skip counting. 45. 45 plus 15 is 60. 75, 90. So that's 1, 2, 3, 4, 5, 6. So 6. 15 times 6 is 90. 90 minus 90 is 0. Bring down my 8. And how many 15s are in 8? 0. So 60, remainder 8 is what I have. You could make that a fraction or a decimal. So I could say 16 and 8/15. Could add a decimal point and keep going. But what I notice is that I can make 60 bracelets. I have enough beads for 60 bracelets, or Tara does. But Tara does not have enough beads for 61 bracelets because we have just this remainder, this fractional part. So she does have enough for 60, does not have enough for 61. So how many bracelets can she make? She can make 60 bracelets. Question number 34. Books in a library are arranged by the Dewey Decimal Number. The Dewey Decimal Numbers for 5 books are shown in the picture. Lana will put these 5 books in order from least to greatest. Which book will be in the 4th position? So the best thing to do here is use your sideways notebook paper. And so let's see if it'll let me change this one. And there we go. So I have my sideways notebook paper. I'm going to choose one of these to be my decimal. And I'm just going to fill in all of my numbers. So 4, 1, 9, decimal, 0, 1, 8. Next number, 4, 1, 7, decimal, 9, 7, 4, 1, 7, decimal, 3, 0, 9, 4, 1, 8, decimal, 5, 3, 7. So I'm lining up my decimals. 4, 1, 8, decimal, 6, 3. Now I do have some gaps. I want to fill those gaps in with zeros. And I'm just going to compare. Now, I like to think about this as money, and so I'm going to not worry about the nonsense unless I need it. So I'm going to ignore that for now. So I'm going to look here, and my least or my smallest, so I'm going to look at just my whole numbers, $419, $417, $418. So the smallest is $417. So I have $417.97, $417.30. So $417.30 is my smallest amount, so that's number 1. $417.97, that's my second smallest. Now I need to go to my $418. So $418.53 is in third place. $418.63 is fourth place. And the largest is my $419.01. So again, I'm ignoring the nonsense. If I don't need it, I don't need that thousandths place, then I'm not going to worry about it. I'll only use it if I need it. So $418.63 is going to be my answer. Now again, it's not really money, but that's just how Mr. Ermins likes to think of it because it makes decimals easier. All right, number 35. Marcia bought a birthday card for $2.86 and a pen for $1.87. So 1 and 1, so I don't have to multiply anything. That's good. Paid with a $20 bill. How much change should Marcia receive? So first thing I need to do is I need to add these two numbers together. So $2.86 plus $1.57. When I add those together, I get $4.43. And then I subtract that because this is her change. Subtract that from the $20 bill that she paid. So $20 minus the $4.43 that she paid. And then get to do this thing. 10 minus 3 is 7. 9 minus 4 is 5. 9 minus 4 is 5 again. And 1. So she got $15.57 in change back. I could eliminate B because I know that there's no way if she paid with a $20 bill, she got more money back. You could probably estimate and get reasonably close and narrow it down to 2 answer choices. But the best method is just to go ahead, add those two together, subtract that from 20, and get your answer for sure. 36, and we're almost done. The ordered pairs below represent 3 of the vertices or the corners of a rhombus. 4, 9, so I need to graph these. Start at the origin, run 4, jump 9. Start at the origin, run 6, jump 7. Start at the origin, run 4, jump 5. And so I need to make a rhombus out of these. And so when I connect to these, it looks like to make a rhombus, I'm going to have to put this point here. And that's going to make my rhombus. And this point, as I start at the origin, I run 2, jump 7. So I'm looking for run 2, jump 7. And yep, sure enough, I do have the answer choice for which ordered pair could represent the 4th vertex of my rhombus. Last question for today. Amy cut 32 feet of chain into pieces that were 1/4 of a foot long. How many of these pieces did Amy have after cutting the chain? Well, we talk about this over and over again. With division, I have some whole amount, and I'm splitting it into groups. My whole amount in this case is 32 feet, splitting that into 1/4. Now, I could draw 32 circles and split each one into 4. But when I draw one circle, I split this one circle into fourths. I now have 4 pieces. 1, 2, 3, 4. If I were to do that 32 times, what I end up having is I have 32 times 4, right? And so 4 times 2 is 8. 4 times 3 is 12. That works. Or I could use either of the strategies that I've learned of 32 divided by 1/4. Start with a whole number. I end with a whole number. 32 times 4 is 128. Or I could say 32 divided by 1/4. I'm going to use keep, change, flip. I need to make that become a fraction. I keep 32 over 1, change my division to a multiplication, and flip my 1/4 to become 4 over 1. And then 32 times 4 is 128, just multiplying across. 1 times 1 is 1, and then 128 divided by 1, or 128 wholes, is the same as 128. So we looked at 3 different ways, modeling it using my 5th grade strategy, and then also using the keep, change, flip, which becomes very powerful in 6th grade. Now the hardest part here is, where does my decimal go? And I know that 128 is the same as 128, right? So if I talked about money, I could say that either of those is 128. So my decimal is behind the 128. So I know that I put my decimal there. So 128, go ahead and bubble that in. That's a little messy. But 128. You could bubble in the 0, 0, or you could leave it blank. Either one will be correct. And that's our portion of the StarSim review for today.